Okay, in RAM we have memory for the application, database application. In that we have cache memory, that is buffer pool management. It uses cache memory. Okay, now we have hard disk. This is buffer pool manager, and this is cache or buffer pool, anything we can say. Now whenever data access layer requested, storage layer requested some pages, it get from the cache if available. If not available, then requested from the hard disk. Okay, this the workflow we know. So we know what are the operation it is doing. One is in read operation, and next is write operation. These are the two DML operations doing by the query processor. Sorry, engine, database engine. Database engine is doing this to read and write operation. For read operation, it is retrieving the data from cache. For read operation, it is retrieving from the cache. For write operation also, it is retrieving, updating in the retrieving from the cache and updating those pages. Okay, and finally flush into the hard disk. Now for all operation, buffer pool fetch data from this cache only, not from hard disk. Then we have constraint is we have limited amount of memory. Suppose this is the hard disk. Hard disk contain multiple data set. For that data set, limited amount. We know that we cannot able to put total amount of memory whatever available for the respective object, like a table. Those whole object we cannot able to put in the RAM, in the cache. Otherwise, what is the use of hard disk and RAM? So we have limited size of RAM available for the buffer pool for the respective cache. Now for each operation it is retrieving from the cache only. Then if new operations are coming, so then what is it will do? It need to do remove the old pages. If new operations are reading of the new pages is happening, then it is retrieve that new pages from the hard disk and store in the RAM cache. Then it RAM become this cache size is we have given the limited size. This size get full, so no enough amount of memory is available for the new DML operation, like new query operation or new write operation. Then what it do, it remove the old pages whatever available. Okay, there are some algorithm is there, we'll discuss if time. With based on that algorithm, it remove the pages. Okay, and which operation it is doing for the respective page, it must should maintain in the cache. Okay, now the process of removing is nothing but the eviction of the cache. Okay, okay, now when eviction is need to do, we know we have to design our database purpose is durability. If eviction is do, that data will not available in hard disk, then we fail the durability of the application. That means we need to flush whatever data we are evicting. Okay, then we have one scenario. Synchronously now RAM will full with pages. Now new requirement is new page is requested by the storage layer from query engine. Then storage layer request the pool to the new page. If new page is not available but RAM is full, then how it need to pool will retrieve the page from hard disk, but it need to insert in first cache. then only after that it give to the access layer, access method. But in order to store that page in the cache, memory is not available. Okay, then we need to evict that memory. If evict that pages, this whole pages, if we try to start the eviction, we say that we lose the durability, because these pages must and should sync with the pages which are available in data hard disk. Then in order to sync, we need to flush these pages. Okay, so during eviction of pages, first step is we need to flush the pages. This will guarantee the durability. Then we need to evict the pages. Okay, so we know that eviction is happen whenever the memory is full. Whenever memory get full, for new request to process the new request, there is not enough available memory is there, then memory get pressure. Due to that pressure, eviction will be start. That means eviction will be start only until whole memory full. But we said in order to get durability, we need to flush that page. In order to evict, we need to first flush. Now before eviction this whole memory, we need to flush. Then whenever we start the flush, this whole memory, that make IO struck. That means we are not large amount of time is consumed by the IO to process this buffer application only, and large amount of time is consumed to flushing the whole pages. Suppose if RAM is 1 GB RAM is there allocated to the pool buffer pool, during flushing, if 1 GB is whole full, now for the new requirement memory get pressure, it need to be flushed. During flushing this 1 GB, IO will take large amount of time. It get stuck with other process, something other process get disturbed. To avoid this, we need to start the flushing before the eviction. That means we need to periodically flushing of the pages. Okay, this is the memory. Here already this amount of pages are there. Now this is the empty. We start the flushing periodically after certain time, whether full, we are not concentrating if during the eviction time, it will flushing periodically. Then eviction is simply clearing the memory itself, not doing the hard disk operation, file operation, IO operation. Eviction is just clearing these pages. Eviction will take little amount of time, but before eviction flush is not happen. We are doing synchronously flushing, then eviction, that make time. Okay, if page content are in sync with disks that were already flushed or were never modified, and the pages is not pinned or referenced, it can be evicted right away. Okay, what the point we are saying here, if page content are in sync with disk, that means that were already flushed or never modified, and the page is not pinned, it can be evicted right away. What it is saying, that in RAM, not whole all pages will be evicted. Some pages having pin, if pin is there to the respective page, that means that these pages cannot be evicted. Okay, this is the first point. If pin is there, we cannot able to evict that page. Second, it is saying that if page is not sync with hard disk page, that means it is dirty, it is modified, or newly added page which is not yet synced with database, file hard disk, then that pages also we cannot able to evict. So only we can able to evict the pages which are not pinned and which are not dirty. That means clean pages and without pinned we can able to evict it. Okay, next thing, since triggering a flush on every eviction might be bad for performance. Okay, some database uses a separate background processes that cycles through the dirty pages that are likely to be evicted, updating their disk version. Like for example, in Postgres we have background flush writer. Okay, in SQL Server we have lazy writer. The point why it is saying that since triggering a flush on every eviction might be a bad for performance. Just now I covered this point. Some database uses a separate background process that cycles through the dirty pages that are likely to be evicted. Okay, updating their disk version. For example, Postgres uses a background. What background process is doing? Okay, another important point to keep in mind is durability. If the database has crashed, all data that was not flushed is lost. To make sure that all changes are persisted, flushes are coordinated by the checkpoint process. Okay, flushes are coordinated by the checkpoint process. Checkpoint process is nothing but periodically it is flushing the data. Okay, checkpoint process control the write ahead log and page cache and ensure that they were in lockstep. This point what I am saying here is checkpoint process. We know that checkpoint is periodically flushing the data file in the file disk or in the hard disk. Okay, this is the simple one line point. The now statement is checkpoint process controls the write ahead log. Control write ahead log and page cache, and it ensures that they were in lockstep and only log records associated with operation applied to the cache pages that were flushed can be discarded from the wall. Okay, now checkpoint responsibility is flush the data pages in the file disk, but whenever certain already it is sync file, no one is modified, sync page which is no one is modified, it is clean. Now we have done some operation, DML operation, someone is updated certain rows of the respective page. Now that this page become dirty. Okay, now after it became dirty, checkpoint will take flushes this page to the file disk, but before flushing, checkpoint must know that for this DML operation there are the log records are there. So these log record first need to flush in the file disk. If it is not flushed, log record is not flushed in the file disk, then these dirty pages cannot be flushed to the data page in the file disk by the checkpoint. So first checkpoint what it do, it need to flush the log record, then after it need to be flush the data pages. Without log record we cannot flush. That is the point, otherwise it become recoverability problem, means inconsistent data. That point we can cover in previous video, that uh, log record must be flushed during commission time and during checkpoint time, and one other is there, another thing, I think I missed. Okay, next thing is, okay,